Finally, we are going to practice past exam papers to know how to state the answer from the questions. My advice for you, read the question clearly, slowly, and start from the given always. So that is 24-25, first session. In the first question, he said the table below gives some values of the function f of an x using the trapezium rule. Find the answer of. So as you know, trapezium rule is I have rule for it. So to state the value of h, the trapezium rule area approximately equal h over 2 times the first value of y plus the last value of y dot plus yn, plus 2 times the sum of all between y1 plus y2 till yn minus 1. And that rule is given in the file. So if the table is given, you can state the value of h between the distance between any two consecutive value on x. So the value of h here, it will be equal between 1 and 2, I have 1. 2 minus 1 or 3 minus 2. Okay? That is the values of y. Y dot, y1, y2, yn, or y3. So the first value of y, 3. The last value of y, 0.75. So now just apply the formula, area. It's approximately equal, not exact. The value of h, 1 over 2, open bracket. The first value of y, 3, plus the last value, 0.75, plus 2 times the sum of all between. What between 3 and 0.75? 1.5 plus 1. Then insert that in your calculator to get the answer, and that represents a square unit because it's area. So insert that in your calculator to get the answer. What is the final answer? Show me. It will be 4.375 square unit. It's finished. Now we are going to the next question. It's a multiply choice question, and it's vector in column vectors. So we have here, shade the bubble next to the vector given by. We just multiply 2 times 2. 2 times negative 4, negative 8. So the answer is given. It's here. Nothing else. Next. Given the complex number z is equal 1 minus 6i, let z conjugate be the conjugate. He talk about conjugate, so we just copy it. The conjugate means we change the sign of imaginary. So if that 1 minus 6i, it's a conjugate, it will be 1 plus 6i. Now, find 3 times z conjugate. So just multiply 3 by the conjugate, which is 1 plus 6i. 3 times 1, it will be 3. 3 times 6, it will be 18i. Expanding only. And that is the final answer. You get 3 marks. Next question. It's a standardized normal random variable, z distributed normally for 0 and 1. And as you know, if you have z, that means you will use a table. Shade the value of z below 0.6. And you know that. We just look for the table if z positive and the area below or on the left. So we just state that directly from the table. Look at the table to state 0.6. So the table in the exam is given. 0.6 here. Go to the table. That is 0.6. It's 1 decimal digit, so it's 0.60. It will be 0.7257. So the answer 0.7257. 0.7257, that is my answer. Next question. The random variable, what is the given here? It's x. It's not standardized, it's a standard. So to change that from standard to be in standardized, we use that formula. Z is equal x minus mu divided by sigma. So that is the mathematical notation. And everyone know that the mathematical notation is x distributed normally for mu and sigma squared. We just write the mathematical notation to state the values of mu, which is the mean. So mu here equal 45. And compare to find the value of sigma. Sigma squared equal 5 squared. So squared cancel together. So sigma it will be equal to 5. I cannot use a table if the variable is x. We just use a table for standardized where the mean is equal 0 and the standard deviation is equal 1. So if you got an x, I will write mathematical notation to state the value of mean and sigma. Then we will use that formula. How that? We just do that here. It's probability given x greater than means on the right, and it's shaded here, 52. First of all, we will change that x to z using that formula. The value of x here, it will be 52 minus mean, it's equal 45, divided by sigma, which is 5. So evaluate that probability of z greater than 1.4. So now that means the mean it changed to be 0, and that value it changed to be 1.4. And everyone know if you have area on the right, we use that, the total area under the curve equal 1. So it will be 1 minus area below, because we just use a table if area below. So it will be 1 minus, change that sign, it will be z below 1.4. Now we can state the value of 1.4 from the table. It will be 1 minus. So using the table, z less than 1.4, it's only one decimal digit. So that means 1.4, then 0. So it will be 0.9192 from the table. Now evaluate that using a calculator. The answer, it will be 0.0808. So 4 marks for that question. We are going to the next one. It's integration. And as I said before, the integration, we look to the function. I have rule for sec squared, but first we look to the function here. It's a basic rule or not? It's basic because it's linear. So we just integrate using the formula. Integral of sec squared, it will be tan for the same angle. And the outside here I have 10. Also we divide by a number with the x, which is 5, all of that plus c. So simplify more equal, 10 over 5, it's 2 times tan 5x, all of that plus c. Did you have that? Yeah, 2 times tan 5x plus c. In the previous or the next one, I have integral of e. We look to the function. It's basic rule because it's linear, so we just follow the rule. 6 e to the power 2x minus 1. We divide by a number with the x, which is 2. All of that defined from 0 to 3. So it's equal 6 divided by 2, it will be 3. E to the power 2x minus 1. It's defined from 0 to 3. We didn't adding c here because I have limits. So if you have limits, we just open two brackets. Between these two brackets, I have minus. In the first bracket, we substitute every x by upper limit. Just substitute. So 3 still, e to the power. Now, replacing x. 2 times 3, it's 6, minus 1, it will be 5. In the second bracket, we substitute every x by lower limit. for the same expression. So it will be 3 e to the power. Now substitute x by 0. 2 times 0, it will be 0 minus 1. It will be e to the power negative 1. To simplify more, you can keep it like that. 3 e to the power 5 minus that e goes down to be positive. It will be 3 over e. You can leave it in terms of e or evaluate using a calculator. So I got the final answer and 4 marks. Now in next one, it's for the vectors. He said for the points A and B with the position vectors. First of all, what is the position vectors, mister? It's starting from the origin. So he said, find the magnitude of A, B. So since A and B are position vectors, to find the relative displacement between any two position vector, we just do that second minus first if they are position. Now we just substitute. What is the second is given? It's 7, 2, and 5. Minus the first, it will be 4, 2, and 1. So the vector AB, it will be 7 minus 4, 3, 2 minus 2, 0, 5 minus 1, it will be 4. Now to find the magnitude, it's equal the modulus. And as you know the modulus, it will be root of the first one squared, or x squared plus y squared, which is 0, plus z squared, which is 4. So the final answer, insert that in your calculator, 9 plus 0 plus 16 root of 25. So the final answer, it will be 5. Next question. The complex number z is equal 3 minus 3i. Write z in the form. That form is called the polar. So it's very good to coming for like that topic, because I want to talk about this. In the complex numbers, I have 3 forms. The first one, in Cartesian form, or in x and y, it's z equal x plus iy. But if you wanted to find the value of x using r and theta, where r equal the modulus of z, and theta, it's equal the argue of z. X always equal r cosine theta, and y equal r times sine theta. You need to memorize that rules. If you substitute using x and y in the first form, you will get the second form, which is r times cosine theta plus I sine theta. That is called polar form. And using r and theta also, you can state the third one. It's called the exponential form. It will be r times e to the power I theta. So that is the relationship between the complex number, or the forms of complex number. So the Cartesian in x and y, and always x equal r, where r is the modulus of the complex number, times cosine theta, and y equal r sine theta. I have 3 forms. The first one, it's called x and y. The second one, it's called polar form. To find it, we need to find the magnitude, which is r, and argue, which is theta. And the third one, it's called exponential, because it's involving e. To find it also, we just need to state the value of r and theta. So we back to our question now. He said the complex number equal, write z in the form. This form is called polar. Maybe he changed the question to ask you find in polar form. So to find polar form, we just need to find the modulus and the argue. So what is the modulus? R is equal modulus of z. So is equal square root of modulus of z equal 3 squared plus the second one, it's negative inside bracket. squared. So the answer, using a calculator, I think it will be 3 root of 2. Now to find the argue, z or theta, I need to know the position. And always, if you want to evaluate the argue in complex, you need to change your calculator to be in radians. If you want to find the direction in vectors, change it to degree. So here I have complex. I will check if my calculator is radians or not. Then we look for that. Always we have that is real on the x and the imaginary on the y. What is about the real? It's positive or negative? It's positive, so it will be here. So imaginary, it's negative, it will be here. And as you know, if it's in fourth quadrant, it will be negative theta. So the argue here, it will be negative, and substitute theta by tan inverse for y, which is 3 in positive sign because the sign to no position, divided by x 3. So the final answer, it will be, evaluate that. Tan inverse of 1, it will be pi over 4, so it will be negative pi over 4. Now I have theta and I have r. So z in polar form is equal. Substitute r, it will be 3 root of 2. Substitute theta, it will be cosine negative pi over 4 plus I sine negative pi over 4. But you need to notice that if sine is negative, if the sine of the angle is negative, the sine of the middle, it will be changed, because sine negative theta equal negative sine theta, but cosine negative theta, it's equal positive cosine. So since the angle is negative here, we will change the sign of the middle. It will be 3 root of 2 times cosine. We change that angle to be positive, and we just change that sign, minus I times sine pi over 4. And also, if you got polar form with negative sign in the middle, so that refers to the angle is negative value. In the next question, A and B are two normal distribution curves. And everyone knows the normal distribution have two parameters. Mu, which is the mean in central location, divided the curve into located parts. Sorry, in two indicated parts, each of which has area equal 0.5, because the total area under the curve equal 1. But sigma, which is a standard deviation, of variance, which is sigma squared, effect n spread out. So how that, Mr.? Here he said A and B are two normal distribution curve. The standard deviation of A greater than. Standard deviation of A greater than. So that means the curve A, it will be shortest than in the height, the curve A, and the more wide and the more. So which one is shortest here and the more wide? I think the first one. Why? Because sigma effect on spread out. Sigma is bigger, so the curve it will be short and have more wide. Sigma is smaller, it has more height and it will be thin. So the next one, integral of 1 over 8x squared plus 2 equal 1 over 4 tan inverse. Always if you have question and the answer coming together, so we just need to solve and then compare my answer with the given answer. I know that if I have in denominator x squared plus a number, so that means tan inverse. And he gave you that here, it's tan inverse. So we just do that, integral of 1 over. To use tan inverse, the coefficient of x squared must to be positive. So I will take 2 as a common factor, as a common factor down, it will be 1 over 8. When we take common factor, we divide every term by that common. So divide now at x squared divided by 8, it will be x squared. 2 over 8 divided by using a calculator, it will be 1 over 4 respect to the x. I need to rewrite this to looks like formula to be easiest for me. 1 over x squared, I know the formula, 1 over x squared plus a squared. So take a square root for 1 over 4, it will be 1 over 2, all squared respect to the x. Now, we state that the value of a is equal 1 over 2. So it's equal 1 over 8 still outside, it goes down. Now, 1 over a, 1 divided by 1 over 2, times tan inverse, that is the rule. X over a, x divided by 1 over 2. All of that plus c. So simplify more, use a calculator to evaluate that. It will be 1 over 4 times tan inverse. Use a calculator to evaluate that expression. x1, the coefficient of x here is 1. 1 divided by 1/2, it will be 2 times x. All of that plus c. Now compare that with the given answer. So we noted that here the coefficient of x equal 2, but the coefficient of x in the given answer, it will be p. So the value of p here is equal what? Is equal positive 2. Vectors. We know that to adding vector geometry, we just starting from the beginning of the first to the end of the last. Read the question given AD equal A. So from A to D, he gave me the direction. And BA equal B. From B to A, it's gave me the direction. Find AE. We just joined that from A to E. And put the direction. In terms of A and B. So it's good. We just work for the closed area. It's starting from here till here. And the rule from the beginning of the first to the end of the last. That is closed area or not? Yeah. So that has length B in opposite direction. So it will be negative B. So just write that from A to E. It will be negative B. Followed by that, it's have the same direction for the opposite one. And he said here, E is the midpoint of BC. So if that A, that it will be A over 2, and that also it will be A over 2. So that it will be A over 2 in the same direction, and that is the final answer. So, mister, we can't find it from another solution or using another area, closed area? Yeah. I just work for what? Closed area, for closed area. So you can find it from that closed area. How? That's at the beginning, correct? So that means it's that side, followed by that side, followed by that side. So here it will be A. Followed by this, it's opposite to B. In this opposite direction, it will be minus B. Followed by this, in the opposite direction, it will be negative A over 2. Then we adding A minus A over 2, it will be positive A over 2 minus B. The same answer. So we just work for closed area. You can do it for this shape or this shape. Given that it's a complex because I have I cubed, and as you know, I cubed is equal to negative I. So first we will substitute that. 4 times 1 minus. We're replacing I cubed by its value, negative I times negative 2, it's a positive 2I. All of that is equal 4 plus A plus 5I. So it's a very important point to know if you have to equal complex number, so that means real equal real and imaginary equal imaginary. So simplify that first by expand. 4 times 1, it will be 4. 4 times 2i, it will be 8i. It's equal, sorry, here plus. It's equal, in other side I have 4 plus a plus 5i. Now you have to equal complex number, and we noted that imaginary it's equal to imaginary, and also real are equal. Each real here equal 4. So to find the value of unknown, we're just equating the imaginary. So a plus 5 equal the coefficient of I here, it will be 8. Shift 5 to other side, it will be a equal 8 minus 5 is equal 3. So that is the final answer. So in mathematics, we just follow the rules. Here the standardized normal distribution, it's standardized because it's z, mean equals 0, and the standard deviation is 1. So we just use the formula or the rule. Direct with the table. That area here between two value, 1.2 and negative 1.5. And as you know, to evaluate the area between two value, we just do that. Area below 1.2 minus area below negative 1.5. So we will write that it's equal probability for z below 1.2 minus probability of z below negative 1.5. We use a table for z positive and the area below, so we can use a table to state that. No problem here. So we look to the table to state the value of 1.2. So 1.20, it will be 0.8849 from the table. But I have problem here because we just use the table of the value of z is positive and the area below and the area below or on the left. Here the value is negative, so and everyone know that if you have negative, we just use symmetrical. And in symmetrical, we change the area. Here z less than negative 1.5, so I need to find that white area. In symmetric, the value changed from negative 1.5 to positive 1.5. In symmetric also, we get the reverse area or the inverse, that on the left, so in the opposite direction it will be on the right. And you know that to evaluate area on the right, if you have positive value, we just do that 1 minus area below that value. So we open bracket here and we just do that. It's 1 minus probability of z, remove negative less than 1.5. So it's equal 0.8849 minus open bracket, that is 1 minus. Now 1.5 is positive, and you know I want the area below that, so we can state that from the table. 1.509332, it will be 0.9332. We just insert all of that in your calculator to get the final answer, and it's finished. So after using a calculator, it will be 0.8181 hashtag we love math. In the next question, he said check the bubble next to the integration respect to x. So I want to find the integral of cotan 7x respect to the x. As you know, in integration or in basic rule, I have only integral for sine and cosine. Sine and cosine only. And for quadratic rule, I have integral of sec squared and cosec squared. But we didn't have rule for tan or cotan, so that means we will replacing it by cotan, it's a cosine for the same angle over sine 7x respect to the x. And in general, we tested the derivative of denominator. If you have fraction, you try to write it as rewrite it as f prime over f. So test the derivative of denominator here, d respect to dx for the denominator, which is sine 7x. Using the rule of differentiation from first semester, differentiation of sine, it will be cosine 7x. And we multiply by a coefficient of x inside it will be what? 7. So compare that with the numerator. I have cosine 7x, but I didn't have 7. So to complete the derivative, we just multiply by 7 and divide outside by 1 over 7. So now I have f prime over f, and as you know, if you have integral of f prime over f, that 1 over 7 goes down, up derivative of down, so it will be ln for the modulus value of sine 7x, all of that plus c. Did you have it? Yeah. 1 over 7 ln 7 sine 7x plus c, that is my answer. By using partial fractions, find. So the partial fractions, 3 types. And always we split only the proper fraction into partial fraction. So how to know it's proper and improper? The proper fraction has degree of numerator less than the degree of denominator. So look at this, the degree of numerator, it's x to the power 1. In denominator, x times x, it will be x squared. So only we split the proper fraction. Okay, mister, what if the degree of numerator equal or less than or greater than the degree of denominator? It's called improper, and we just need to use long division to convert it from improper to be a whole number plus proper. But the proper fractions have 3 types in partial fractions. Proper fraction with distinct linear factor like this. What's the meaning of distinct linear factor? It's easily seen. I have to factor, each of which is linear, means x inside raised to the power 1. And that is the easiest type. So come for this one, it's equal, we just take that fraction inside. 1x minus 1 over x plus 2 times x plus 3. I have 2 factors in denominator, so we just use partial fraction if we have more than 1 factor in denominator. So we just split that into equal fraction or sum of 2 fractions. The first one take a factor, the first factor as a denominator. The second take the second factor as a denominator. Where up I have 2 constants to be found, a and b. Now, to simplify that or to remove denominators, we multiply all fractions by the original denominator, that one, x plus 2 times x plus 3. We just multiply all terms. X plus 2 times x plus 3. X plus 2 times x plus 3. Now we start to simplify. That divided by itself, it's cancelled. So the remaining here, it will be x minus 1. Here, sorry, it's x plus 2 times x plus 3. So that it will be x plus 2 down here. X plus 2 cancelled with x plus 2. So the remaining, it will be a times x plus 3. Here, x plus 3 cancelled with x plus 3. So the remaining here, b times x plus 2. That is the most important identity. Why? Because I just need to state the values of a and b. And that depends on elimination. How to eliminate anyone using the zeros of factors? How that? As you know, 0 times anything is equal 0. So, what is the value of x, which equals 0 here? X plus 3, so if you substitute x by negative 3, I will get 0, correct? Correct? So, if you substitute x by negative 2 here, also I will get 0. So we substitute using h of which. So at x equal negative 3, we substitute every x here. Negative 3 minus 1, it will be negative 4. Is equal, negative 3 is 0 of a, so it will be eliminate a. Negative 3 plus 2, it will be negative 1 times b, so that means the value of b is equal 4. Use the other 0 or the second 0 at x equal negative 2. Negative 2 eliminate b. So substitute every x. Negative 2 minus 1, it will be negative 3, is equal. Negative 2 plus 3, it will be 1 times a, it will be a. So the value of a, it will be equal negative 3. Now we will back to our integral and substitute that fraction by that it's a partial fraction. And don't forget that I will replacing a and b by their values. So the first one has value of a, it's a negative 3 over x plus 2. The value of b, it's a positive 4 over x plus 3. All of that respect to the x. So it's equal. We have a rule for that. It's a negative 3 ln for the modulus x plus 2 plus 4 ln for the modulus x plus 3, all of that plus c. So Mr. told us we have 2 types or 3 types of partial fractions. So that is called distinct linear factor, means it's easily seen to see linear factor in denominators. So what is the other type? For example, if you got question like that, it's different questions using partial fractions. Find the integral of 2x minus 1 over x minus 5 all squared. All of that respected to the x. So focus with me. That type is called, I have repeated linear factor in denominator. Means one factor but repeated more than one time. Maybe 1 time or 2 times or 3 times. Also, if you have x squared only, it's a repeated factor. It's x times x. So what we have to do here, we just do that. Take the fraction inside. 2x minus 1 over x minus 5 all squared is equal. I have one linear factor repeated 2 times, so I will do 2 fractions. The first fraction, take the first factor, x minus 5 to the power 1, all right? All right? So the second one, it will be x minus 5 all to the power 2. Okay, what if I have 3, mister? It will be the third one, x minus 5 to the power 3. It's counting. And up I have a and b to be found. Again, if you have repeated linear factor in denominator, we just express like that. The first factor, x minus 5 to the power 1. The second, x minus 5 to the power 2. So if you have power 3, it will be the third plus c over x minus 5 to the power 3. And by the same way, to remove the denominator, we just multiply all by the original denominator, which is x minus 5 all squared. Attention, x minus 5 all squared, x minus 5 all squared. Why? To state the most important identity. That is cancelled. We just do that to remove the old denominators. So I got here 2x minus 1 is equal. Here the bracket repeated 2 times, so the squared cancel with the denominator. So I got a times x minus 5 plus anything divided by itself, it will be cancelled. So the remaining here, it's only b. So notice that here I have only 1 0 at x equal 5. So I have only 1 0 at x equal 5. We can use 5 to eliminate a to find the value of b. So, mister, how to eliminate b? We will check that. So we use that first at x equal 5. So we have 2 times 5, 10, minus 1, it will be 9, equal 5, eliminate a. So I got b. So I have the value of b. Okay, now I want to find the value of a. What we have to do? Choose any value for Lx rather than the first choice 5. Any value. But don't forget that you will substitute b by its value also. So, for example, at x equals 0. 2 times 0 cancel, it will be negative 1. 0 times negative 5, it will be negative 5 times a. What about b? We substitute it by its value, which is positive 9. Now we can solve it to find the value of a. So negative 5a is equal. Shift 9 to other side. Negative 1 minus 9, it will be negative 10. So the value of a here is equal negative 10 divided by negative 5. It will be equal positive 2. Now we back to our question. So it's equal integral of, substitute a by its value, it's 2 over x minus 5, plus substitute b by its value, it will be 9 over x minus 5 all squared, all of that respect to the x. So noted that here the bracket raised to the power 2, not to the power 1. So you need to change that to be x to the power n. So it's equal integral of 2 over x minus 5 plus 9, and that goes up to change the sign because the power is not 1. It will be x minus 5 all to the power negative 2. All of that respected to the x. Now how to integrate that, mister? We just do that. 2 ln of denominator, because that is linear. Here we adding 1 to the power x minus 5, negative 2 plus 1, it will be negative 1. Then divide by a new power, 9 over negative 1, it's a negative 1. It's negative 9. And the coefficient of x inside is 1, all of that plus 3, and that is the final answer. So Mr. You said I have 3 types. That is the easiest type. That if you have repeated factor in denominator or repeated linear factor. So what about the third one, mister? The third one, it's called a reducible quadratic factor in denominator. So means quadratic factor cannot be factorized. I will explain it now when we get space. Now we are going to the next question to complete our exam. Here he said the vector b is equal, makes an angle. The vector and complex both common at a lot of things necessary to find the angle, but the angle in vector, it's called the direction or an angle with an eye, because the x-axis represent I component in the vectors. So to find the angle, first inside vector, first change your calculator to be in degree, then focus that is I, and here j, I want to know the position of that vector. I here, it's positive or negative, so it will be negative here. J is positive, it will be here. So everyone know the angle in second, it will be 180 minus theta, where theta it's tan inverse y over x. So the angle here, it will be equal 180 minus tan inverse for the value of y, which is root of 3, over x, it's a negative 1. No, it's a positive 1, because we just take positive, the sign, to know the position in degree. So evaluate that. So the answer, it will be 120 degrees. So I have it here. So we are going now to the next question. He said 2 vectors a and b are given by. So it's better in vectors to convert all vectors to be in column vectors. So here it will be a equal, the coefficient of I is n, the coefficient of j, it will be 1, and b, it will be, coefficient of I is 1, coefficient of j is 2. Now always we start from the given. He said 3 times a, so we substitute a by its value, which is n and 1, minus b, which is 1 and 2. All of that is equal. We change that also to be in column vector. It will be 5 and 1. Now simplify. 3 times n, it will be 3n. 3 times 1, it will be 3. Minus 1 and 2. All of that is equal 5 and 1. Now just subtracting 3n minus 1. 3 minus 2, it will be 1. Equal 5, 1. As we did precisely in complex, also in vectors, if you have two equal vectors, that means they have same magnitude and same direction, and the corresponding members are equal. So that means the coefficients or the components of I are equals, and the j are equals also, each of which is equal 1. So to state the value of n here, we're just equating that 3n minus 1 is equal to 5. So shift 1 to other side, it will be 3n equals 6. So the value of n here equals 6 over 3 is equal 2. That is. In this question, given that a complex numbers are z1 equal 4 plus 2i, 5z2 equal 15 minus 5i, find z1 times z2. So z1 I have it, but here I have 5z2. So to find z2, we just divide all by 5. We divide through 5, so 15 divided by 5, it will be 3. 5i over 5, it will be I. Now to find z1 times z2, so we need to multiply z1 by z2. z1 is given 4 plus 2i times z2, 3 minus I. We expand by multiply first term by every term in the second bracket. So 4 times 3, it will be 12. 4 times negative I, it will be negative 4i. Then take 2 and distribute by multiplication in the second bracket. 2i times 3, it will be positive 6i. 2i times negative I, it will be negative 2i squared. And as you know, I squared equal negative 1, so it's always cancelled, and we just change that side. And you know that it changed from imaginary to be part. Now, collecting like terms or adding like terms, so I got here 12 real plus 2 real, it will be 14. Negative 4 imaginary plus 4 imaginary, so plus 6 imaginary, so negative 4 plus 6, it will be positive 2i. To finish. Then the next one, the random variable x distributed. If you see mathematical notation in x, that is the standard, not standardized. So I will write the mathematical notation for standard. X distributed normally for mu and sigma squared. That to state the values of mu and sigma. So mu here is unknown, so it's still unknown. Sigma squared is equal 36. But we want to find sigma, so we will take square root. So sigma is equal, third root of 36, it will be 6. So the standard deviation here is equal to 6. So here he said, probability of x less than 30 is equal probability of z. Oh, now that represents the value of z, and that represents the value of x. So means I want to convert x to z. That happen only using that rule. Z is equal x minus mu divided by sigma. So the value of z is equal 0.5. Equal. The value of x, it's 30. Minus mu, it's unknown. Divided by sigma, which is 6. We're stating it from here. Now do cross multiplication. So 30 minus mu is equal, because that was denominator 1. 6 times 0.5, it will be 3. To find the mu is negative. Shifting it to other side to be positive. And shifting that 3 to other side, it will be 30 minus 3. It will be equal to 27. And that is the final answer. And when we was explained the normal distribution, we solve a lot of questions like that in this form or in the opposite form, in graph form. It's so easy. Now, in this question, it's mixed between or half reasoning from grade 11, because that to evaluate the exact area and the exact area from grade 11. He said here the shaded region has area of 10. So he studied that in grade 11, area equal integral from 2 to a for the given curve 7 over x minus 1. All of that respect to the x is equal the area, and he said here area equal 21, so all of that is equal 21. In denominator I have linear expression, so it will be 7 ln for the modulus value of x minus 1. It's defined from 2 to a, all of that is equal 21. To remove that 7, we just divide both sides by 7, so I got ln x minus 1 from 2 to a, it's equal to 21 over 7, it will be 3. We just do that to be clear. Now substitute using upper limit, it will be a minus 1. Minus substitute using our limit, ln 2 minus 1, it will be 1. All of that is equal 3. That is equal 0. To remove ln, we take e as a base, so a minus 1 is equal e to the power 3. So shifting that to other side, so a equal e to the power 3 plus 1. Did you have that? Yeah, that is. Maybe you get like this question as extended. Now we are going to the next question. It's integration by parts. Why? Because it's involving ln. So in parts, always we denote it for ln by u is equal ln x. Why? Because I have rule to differentiate ln x. And the dv is the other term, is 3x times dx. In this question, we differentiate u. Implicitly, the derivative of u, 1 over x dx. And I will integrate v, it will be, we just adding 1 to the power, it will be x squared, and here 3 over. Now, for the rule, u times v, so it's equal 3 over 2 x squared times ln x minus integral of 3 over 2, it's a constant value, stay outside, x squared divided by x, it will be x respect to dx. So now just integrate, it will be 3 over 2, sorry, x squared time ln x minus here, it's raised to the power 1 x, so we're just adding 1 to the power, it will be 1 plus 1, it will be 2, divide by a new power, 3 over 2 divided by 2, it will be 3 over 4, all of that plus c, it's finished. The question of parts, it's repeated a lot. And as you know, parts, a lot of types. So you have parts happen one time, only once, happen 2 times, and we have repeated, all right? I want to give you a question. We have a lot of questions not repeated before in parts. That questions like, for example, integral of x times tan inverse x respected to the x. What if you get like this question tomorrow or next tomorrow in the final exam? It's parts. Why? Because the degree outside equal the degree inside. I told you if you have product rule and the degree outside equal the degree of inside or more than the degree of inside, so that is parts. But here, which one is u? What is u here? X or tan inverse. And what is dv? If you got integral of x times sine x, or x times cosine x, or x squared times sine x, or x squared times cosine x, or x times tan inverse, or x squared times tan inverse, all of this is parts. But in this case, what is u? It's a tan inverse. Why? Because I have rule to differentiate it like tan, like ln. Okay, what is dv? It will be the remaining. I choose tan x as u, so dv it will be x dx. Always we differentiate u implicitly. The derivative of tan inverse, it will be 1 plus x squared from first semester, and the differentiation of x, it will be 1. Now I will integrate that, you get v, it's equal, we adding 1 to the board and divide by a new power. Now follow the rule, it's equal, just multiply here, it will be 1 over 2 x squared times tan inverse x minus the integral of minus 1 over 2, it's a constant, still outside, time integral of x squared times 1 over 1 plus x squared, it will be x squared over 1 plus x squared, all of that respect to the x. So I noted that here I have 1 plus x squared and the up x squared, so we have one way here, that way is split out, then use tan inverse. So it's equal, that goes down, 1 over 2 x squared times tan inverse x minus 1 over 2, then open bracket, integral of 1 plus x squared, and up I have x squared. I told you before in integration, we have only one way to solve that. We just need to complete the numerator to be looks like the denominator. In the denominator, I have 1 plus x squared. So what happens if you adding 1 here and subtracting 1? Why? To keep two terms in the numerator. Now I have only one term in the denominator represented by that bracket, 1 plus x squared. Then we split out, then integrate. So all of that is equal 1 over 2 x squared times tan inverse x minus 1 over 2, open bracket. Now this split that, it's one term in the denominator, so we need to split. So it's integral, that divided by itself is equal 1 minus 1 over 1 plus x squared. All of that respected to the x, close the bracket. So it's equal 1 over 2 x squared times tan inverse x. Note that negative half distributed by every term after integrating. So the integral of 1x times negative half, it will be negative half x. The integral of that, it will be negative times negative half, it will be positive 1 half. Integral of 1 over 1 plus x squared, it will be tan inverse x. All of that plus c. It's a very good question. It looks like ln. And it's tricky. So if you got x times tan inverse, we choose u in parts tan inverse because I have rule to integrate tan. I have rule to differentiate tan inverse, but we didn't have rule to integrate tan inverse. Next question. Given the vector q is equal, find the unit vector. To find any unit vector, what's the meaning of unit vector? It's a vector with a magnitude 1. So it's equal 1 over the modulus of that vector times the given vector. So if he said find the unit vector, I want to find the modulus of that, or the magnitude. So the modulus of q is equal square root 4 x squared 6 squared plus negative 8 squared plus negative 24 all squared. So the final answer here, it will be, so it's equal 26. So unit vector, is equal 1 over 26 times the given vector, that. So it will be 6i minus 8j minus 24k. So expand that. So it's equal 6 times 1 over 26. It will be 3 over 13i. Minus 8 over 26. It will be 4 over 13j. 24 over 26. It will be 12 over 13k. That is the final answer. Now it's a quadratic equation. To solve any quadratic equation in MCQ, we just use mod 3-3. Again, to solve any quadratic equation in MCQ, use mod 3-3 or mod 5-3 in 991. But if it's an extended question, we use the quadratic formula. B squared minus 4 root of B squared minus 4AC divided by 2a. Again, if you got quadratic equation in MCQ, use mod 3-3. So we just insert the coefficient. Here, 991, it will be mod 5-3. Now insert the coefficients. Z squared has 1 equal, negative 4 is equal, positive 5 is equal. I got the first one, 2 plus I and the 2 minus I. So that is. So if you got an extended, use the quadratic formula. Here in the second question, Z1 is equal, that in the polar form. So we state that R1 equal 3 and theta 1 is equal pi over 3. The second one in polar form, so R2 is equal 1 over 2 and theta 2 is equal to pi. So to find the Z1 divided by Z2, when we divide two numbers, we just divide R1 by R2. So R1 it's equal 3 over R2 is equal 1/2. Then when we divide, we subtracting cosine theta 1, which is pi over 3, minus theta 2, which is pi. So we just evaluate pi over 3 minus pi plus I sine for the same angle, pi over 3 minus pi. So 3 over 1 over 2, it will be 6. That it will be cosine pi over 3 minus pi, it will be negative 2 pi over 3. Plus I sine for the same angle, negative 2 pi over 3. I told you before, if you have negative angle, that change it. So it will be 6 times cosine minus, that is 2 pi over 3. So that is the second one, represent the given answer.